In this screencast, we continue our study of solving linear equations. So far, we've looked at the basics. Now we're going to add in some additional things that may happen when you're solving linear equations. So if you take a look at this equation, this is a little bit different than the ones we've seen in the previous one. However, it's still a linear equation. When you look at this left-hand side, does it make you think of anything? You might look at this and say, hey, I can use the distributive property. Well, this screencast is going to focus on solving linear equations where you need to use the distributive property. There's technically a way to get around using the distributive property here, but it's going to cause you to do computations with fractions that you probably want to avoid. So ultimately, in this screencast, you want to perform the distributive property on either side of the equation if you have multiplication over addition, then proceed as usual. So if it's there, you perform it. If not, then obviously you would not worry about it. So let's go ahead and solve this equation right here. So first we're going to distribute the 2 into the 3x and into the 1, and we got 6x minus 2 equals 15. So technically we have not done something to both sides. Remember, equality is all about balance. We've not done something to both sides. We've just changed the left-hand side to something that's equivalent to it. Now, this is just like the equations we were solving in the previous screencast. We undo what's happening to the variable in the opposite order of the order of operations. So x is being multiplied by 6, and then you're subtracting 2 from that quantity, so we undo the subtracting 2 first. And to undo subtraction, we do addition. So we're going to add 2 to both sides. Here now we're doing something to both sides. You're adding a weight of 2 pounds to both sides here, then you're going to maintain the balance. You've got 6x on the left, 17 on the right, and then to undo x being multiplied by 6 is to divide by 6. And we get x on the left-hand side. And in general, we're not going to be converting anything to decimals. We'll just be reducing fractions, but 17/6 is already fully reduced. So our answer is x equals 17/6. Don't forget, your solution is an equivalent equation. So it's not just a number, it's x equals a particular number. So x equals 17/6 is the solution to this equation. And you can always check by plugging that back in and doing the arithmetic to make sure you get a true statement. Let's now practice this with a few examples. So this first example here, you can see on the right-hand side, we should distribute in a -1. Remember, when you take the opposite of an expression like this, that means you're multiplying in a -1. And we still have 11 on the left-hand side. -1 times 1 gives us a -1, and then you've got -1 times 3x is -3x, but you're subtracting that, so it's the same thing as plus 3x. And now, this is a standard equation. We need to undo what's happening to x. So x is being multiplied by 3, and then you're adding -1 to that. The way to undo adding -1 is to subtract -1, which is actually just adding +1. So we're just going to add 1 to both sides, giving us 12 on the left and 3x on the right. And now to undo the multiplication by 3, we should divide both sides by 3. Again, we're doing things to both sides. So we got 4 equals x. That is our solution. And again, to know if we did this right, let's actually just do it for this one here. To know if we did this right, we should be able to plug this 4 back in to the equation for x and see if we get a true statement. So let's just do a quick check. If we plug in 4 over here, we'd have the opposite of the quantity 1 minus 3 times 4 for x. Now, if we do this arithmetic, we've got the opposite of 1 minus 12. And then the opposite of 1 minus 12 is -11. The opposite of -11 is +11, which is exactly what we wanted to get. So we know that this is in fact true. So x equals 4 is our solution, and we've now checked it. And we don't necessarily have to check it, but I can be certain that I did it right if I check to make sure that it actually works. So let's do the next one. And notice here, we've got to use the distributive property twice. When we distribute the 3 into the 2p minus 1, we get 6p minus 3. And when we distribute the 4 into the sum of p and 1, we get plus 4p plus 4 and equals 0. There's an additional tip up here that is very important that you consider whenever you're solving linear equations or equations in general. You always want to combine like terms on each side of the equation when possible. At any point, if you can combine like terms on each individual side, not together, right? You can teach each of the sides individually. If one of the sides can be cleaned up by combining like terms, you want to do that. Of course, you can't clean this side up. It's as simple as it can be. However, this is more complicated than it should be. So let's focus on combining the like terms here. We've got 6p plus 4p is 10p. And then if you subtract 3 and add 4, that's the same thing as adding a total of 1. So notice I did not do anything to both sides. It's not like we added 1 to both sides and divided both sides by 3. Here we just simply combined the like terms. So far we have not done something to both sides. From here to here, we distributed it on the left, did nothing to the right. And then from here to here, we combined like terms on the left, nothing to the right. We are now ready to do something to both sides of the equation. So p is being multiplied by 10, and then you're adding 1. So we're going to undo the adding 1 by subtracting 1 from both sides. And you're left with 10p on the left, and 0 minus 1 is negative 1 on the right. And now to undo what's happening to p, we need to divide both sides by 10 because p is being multiplied by 10. And you get p on the left-hand side, and you're left with negative 1/10 on the right-hand side. P equals negative 1/10 is the solution to this equation. Again, you can check in the same way that we did here. You can plug the negative 1/10 back in for each of these p's, and then do this arithmetic and see if it gives you exactly 0. Let's try this last equation. So you notice we've got some distributing to do in here. And technically, we're distributing in a negative 3 because subtracting 3 is the same thing as plus negative 3. So negative 3 is being distributed in here. We've got 7 plus negative 3 times w is negative 3w. And then negative 3 times 1 is negative 3, but we're subtracting that, so it's the same thing as adding 3. Many of you would say negative 3 times negative 1 gives you plus 3. However you do that is fine. And then don't forget, we still have the plus 2w, and you have equals 20. So we haven't done something to both sides. We're just rewriting the left-hand side as of now. What would be your next move? Well, you always want to do this whenever you can, because there's some problems that some students have when they don't combine like terms. So the idea here is we want to clean up this left-hand side. And if you combine the like terms, we've got negative 1w plus 10 equals 20. Now we need to undo what's happening to w by doing the opposite operations or the inverse operations in the opposite order of the order of operations, i.e. what we did in the previous screencast. So we're going to first subtract 10 from both sides. We're going to get opposite of w equals 10. And then don't forget, opposite of w really means negative 1 times w. So to undo multiplying w by negative 1, you would divide both sides by negative 1, and you get w equals negative 10. And that's our solution. Again, we can plug that back in for this and this w, and if we do the arithmetic and it comes out to be 20, then we know we did it right. Now that we've gotten a bunch of practice using the distributive property in solving linear equations, let's look at a couple of applications. Let's recall a problem from a previous screencast. The Pool Pavers Company specializes in creating paver borders around the perimeter of square in-ground pools. Each paver is 1 square yard. In that previous screencast, we studied this input-output rule pretty thoroughly and figured out that T is equal to 4S plus 4, where S is the pool side length in yards, and T is the total number of pavers. So T equals 4S plus 4. Now we can ask a new type of question that we couldn't have asked in that screencast. If a job requires 68 pavers, set up and solve an equation that tells you the size of the square pool. So 68 pavers, that's a value of T. So we're going to plug in 68 for T. The reason we didn't do a problem like this in that previous screencast is because we hadn't solved equations yet. Now you can see we need to be able to solve equations to answer this question. Well, we want to undo what's happening to S here. Do we need to use the distributive property? If you look at this, it's not like this says 4 times the quantity S plus 4. This is just 4 times the S, and then you're adding 4 onto that product. So the distributive property does not apply here. You don't want to just get happy and try to use the distributive property all the time. You use it when it's appropriate. So let's solve this. Of course, we need to subtract 4 from both sides, giving us 64 equals 4S. And then if you divide both sides by 4 to isolate S, you get 16 equals S. So this pool has side length 16 yards. So the pool has side length 16 yards. Pretty big pool. Notice here for this problem, we didn't simply just end with this. Whenever you're solving an application, you should interpret what that tells you. S equals 16 tells us that the pool has side length of 16 yards. So with an application, you should finish the problem with a brief sentence telling what you found. Let's try another application problem. And this one is similar to something from a previous screencast, but it's altered a bit. So we'll pretend like it's new. So a uniform consists of a pair of shorts and a shirt. Jim remembered that each shirt costs $11, but he can't recall the cost of a pair of shorts. He bought 4 uniforms for a total of $104. Set up and solve an equation that will give you the cost of each pair of shorts. Define your variable. So notice in this new application, the variable is not already defined for you. In the previous one, S was defined as the side length of the pool in yards. T was defined as the total number of pavers. Here, the variable is not defined for you. So you need to start by defining that variable and literally writing down what it is. And you can choose whatever you want. But first, we need to know what are we looking for. And it says it here, set up and solve an equation that will give you the cost of each pair of shorts. So we need to know the cost of each pair of shorts. So we can let X, Y, whatever you want, as long as you write it down. So let's let P represent cost of a pair of shorts. So we want to actually write that out in words. Again, you can choose whatever letter you want, but just make sure you write down what it represents. So let P represent the cost of a pair of shorts. Now we want to set up and solve an equation that's going to give us the value of P. Well, we're told that 4 uniforms cost a total of $104. So we have 4 uniforms cost a total of $104. Well, how much is each uniform? Well, each uniform consists of a pair of shorts and a shirt. The pair of shorts cost was P. That's the letter here. We don't know what it is. That's why we're letting P represent it. And the cost of a shirt would be $11. So these two costs together would be P plus 11. So the cost of a uniform is P plus 11. So we need 4 uniforms at this cost will give us a total of $104. Now we can solve this equation to get our answer. So with this one, would you want to use the distributive property? Well, you notice we've got 4 times this sum. So yes, we'll distribute the 4 into the P and into the 11. Again, there are some other ways to do this, but we're going to just consistently use the distributive property when it's there. So 4 times P is 4P, 4 times 11 is 44, and that equals 104. Now we got to undo what's happening to P in the opposite order of the order of operations. So we're going to subtract 44, which will give us 4P equals 60. Then to undo the multiplication by 4, we would divide both sides by 4, giving us P equals 15. So yes, we just solved this equation, but again, it's an application, so we want to write what this means. And again, we already wrote that let P represent the cost of a pair of shorts, so P equals 15 means each pair of shorts costs $15. So let's just quickly write that. Each pair of shorts cost $15. That is the final solution to this application.